Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fauzal Azim bin Zari and my group members are Muhammad Azim bin Zarin, Siti Nomia Amirah binti Zaki and Shafiq Irfan bin Nur Azman. We are from Group 1 of class EC1104P and today we are going to present early strength sustainable concrete for ECS268 structural material and laboratory project.
So the innovation material that we have choose is straw. The straw that we got, we will cut into the small pieces. We choose straw because straw is a small particle that can replace coarse aggregate for the concrete mix. So we will find the straw effectiveness in mixing the concrete.
And then the advantages of adding straw in the concrete mixture. Straw can help concrete mixture function better. Adding straw to the concrete mix before pouring strengthens the connections between the aggregate and cement, and also forms air pockets that act as an air entraining agent, improving insulating characteristics. The mixture also holds moisture, which delays the curing process and increases the concrete's final strength.
Next, the methodology. First is the mixing fresh concrete. First, we need to calculate all the required cement, sand, gravel, straw and water required. Weigh all the material according to the mixed proportion. Note the room temperature and relative humidity. Wipe the laboratory pan mixer with a clean cloth to prevent cement and fine aggregate being stuck to the inner surface of the pan while mixing. Next, mix the dry constituents thoroughly to get a uniform color and then add water. Then feed sand into the laboratory pan mixer, a part of coarse aggregate, cement, straw, then the water. Let the mixing time be 1.5 until 2 minutes after all the ingredients are added, and then stop the mixer. The next test is the slump test. First, the interior cone mold was cleaned and some water was applied. The mold was placed vertically on a smooth, flat and clean surface tray. There was no vibration occurred during the test. Next, the plate under the mold was tapped on the concrete sample was put in 3 layers inside the mold. Each layer was 1/3 of the mold's height. Each layer was compact by tamping it 25 times using the compacting rod. The tamping was distributed evenly on each surface. Next, the top surface of the concrete was leveled using a trowel. The mold was slowly lifted vertically with caution to allow concrete to subside. Finally, after the mold is lifted, the difference in the level between the height of the mold and the highest point of the subside concrete was measured. This difference in height in mm was taken as slump of the concrete. Next, the compacting factor test. The apparatus was assembled vertically. Then, all inside surface of the hopper were cleaned. Each hopper had a door at the bottom. This door was closed before the commencing the test. The upper hopper was filled up with concrete to the brim. The door was released to let the concrete fall into the lower hopper. The door of the second hopper was released to let the concrete fall into the cylinder. Access the concrete from the top of the cylinder was cut off by sliding it across with 2 floats. The net weight of the concrete was determined. The cylinder was emptied and refilled with the concrete from the same sample in 3 layers. Each layer was stamped 25 times with standard steel rod. The top surface of the cylinder was leveled off and was weighed to the nearest 10 gm. This weight is known as the weight of fully compacted concrete. The compaction factor of the concrete was calculated. With the formula, the compacting equal to the weight of the partially compacted concrete divided by weight of fully compacted concrete. Finally, the casting of cured concrete test. Clean the mold and spread a thin layer of oil on the surface of the inner side. Fill the cube mold in layer approximately 1/3 of the depth of 3 layers each cube. Compact each layer by hand or vibrator. When compaction by hand, apply the stroke of the bar of the uniform manner over the iron section of the mold. When compacting by vibration, compact each layer by means of electric, pneumatic hammer or vibrating table until the specified condition is attained. After the top layer has been compacted, finish the surface of the concrete in level with the top of mold by means of the trowel. Cover the mold with damp sack and store the test cube. After 24 hours of storage in the moist air, demold the specimen. Mark the specimen for later identification in a suitable manner. Immediately submerge the specimen in the water contained in curing tanks, unless they required for the test within 24 hours. Do not allow the specimen to become dry at any time until they are taken to be tested.
The sustainable material that we are using is straw, and the ratio must be correct in order to mix all the materials for the concrete. So these are the ratio for the materials. The water content is 2.4 kg, which is multiplied by 0.3 times 8. The cement is 3.2 kg, which we get from the multiplication of 0.4 kg times 8. Fine aggregate is 5.6 kg. The coarse aggregate is 9.6 kg, and the total of 4.8 kg straw plus 4.8 kg gravel is 9.6 kg. So the result is for the slump test. The sustainable material which we are using is straw, and the height of slump is 180 mm. The type of slump that we get is collapse. The result for compressive strength test after 7 days of conducting the experiment, we need to do 2 specimens, which we name it specimen 1 and specimen 2. The weight for specimen 1 after 7 days is 5.6 kg, and the specimen 2 after 7 days is 5.3 kg. The load maximum for specimen 1 is 19.49 kN, and the specimen 2 is 15.35 kN after 7 days. The compressive strength for specimen 1 is 1.9 MPa, and the second specimen is 1.1 MPa.
Next, the discussion.
As part of replacement in concrete material, we had used drinking straw material as our main coarse aggregate. In this experiment, concrete slump test was conducted to determine the workability or consistency of concrete mix prepared at the laboratory or the construction site during the progress of the work. Generally, concrete slump value is used to find the workability, which indicates water-cement ratio, but there are various factors including properties of materials, mixing methods, dosage, and admixtures. During the lab session, we take an amount of concrete and fill it into the frustum of steel cone in 3 layers. Then we are required to hand tape the concrete by tempering 25 times by using a steel rod. After the steel cone is filled and tempered, we turn the cone upside down and start to measure the slump as downward movement of concrete. The value obtained was 180 mm, which means that the shape of slump is not clear dimension due to the high water-cement ratio. And based on the slump form, we can observe that the slump is very wet and flabby. At the end of the compressive strength test, strength value of the straw cement obtained was lesser than strength value of the solid brick. The strength value of straw concrete was 19.5 49 kN. Meanwhile, the strength value of the solid brick was 93.07 kN. Therefore, we may conclude that the material used to replace coarse aggregate was unable to produce strong structured cement.
Finally, the conclusion. The objective of this laboratory was achieved. Concrete innovation in terms of methods and material use was developed. The psychomotor in handling equipment and apparatus also enhanced. By conducting slump tests and compressive strength tests, we were able to determine the workability and compressive strength of the sustainable concrete mix of grade 30. Through the conducted experiment, we may conclude the material used to replace coarse aggregate was unable to produce strong structured cement. That's all from us. Thank you.